if we make contact with them, I think in this century, we'll probably pick up signals from an extraterrestrial civilization.
Since 1957, humans have been actively exploring space, leading the charge in our pursuit of knowledge. However, it wasn't until the discovery of Oumuamua, our first interstellar visitor, that the notion of us being alone in space began to crumble. In a groundbreaking twist, Michio Kaku, a renowned theoretical physicist and futurologist, has boldly revealed declassified images of Oumuamua. These long-hidden images have sparked debates amongst science enthusiasts and military personnel. Could this be the long-awaited proof of alien life? Why was this remarkable finding kept secret from the public?
Oumuamua is so weird. I wish it never existed.
Let's find out. In 2017, we made an unprecedented astronomical discovery when we spotted an object that we believe originated beyond our solar system. Experts argued about the origin of the strange object, whether it was a comet with an unusual orbit, an asteroid without a visible tail, or a traveler from a distant galaxy. This mysterious object was named Oumuamua, a Hawaiian term that translates to messenger from the distant past, capturing its extraordinary nature. It became a spectacular discovery, providing us with a glimpse into the existence of objects traversing interstellar space. However, despite contrary opinions from other experts, renowned physicist Michio Kaku chose to reveal the declassified images of this mysterious object. Before exploring these images and their shocking revelations about this strange object, let's start from the beginning. How was Oumuamua discovered? Our solar system alone is home to trillions of space rocks, and there are even more beyond its boundaries. Despite the enormous number of these celestial objects, we can trust our spacecraft, telescopes, and lasers work tirelessly around the clock to study them. Each piece of information we gather about these space rocks has the potential to be a game changer at any given moment. We leave no stone unturned as scientists continuously keep a vigilant eye on space. While major celestial objects rarely enter our solar system, and when they do, they tend to be located near the outer edges and must possess significant velocity to endure the immense pressure in that region. The possibility of Earth's machines detecting an interstellar visitor was never considered. However, on October 19, 2017, the Pan-STARRS 1 telescope at the University of Hawaii unexpectedly detected unusual movement. This highly efficient telescope, part of the Near-Earth Object Observations Program, promptly seized the data and alerted the scientific community. The object that it later named Oumuamua intrigued researchers as it defied the norms. Unlike run-of-the-mill rocks originating within our solar system, Oumuamua had traversed the vast expanse of space from outside our solar system and ventured into the vicinity of Earth.
We had enough data to realize that this object wasn't from our solar system.
This feat, considered nearly impossible without apparent propulsion systems, puzzled scientists. With each passing moment, and as Oumuamua drew nearer, many questions multiplied. The object's acceleration, instead of deceleration, as it approached Earth, added an even stranger twist to the story. It was observed that a mysterious object raced past the Sun at an astonishing speed of 87 kilometers per second. This object was named 1I/2017 U1. Scientists observed an intriguing phenomenon with this interstellar object. It seemed to be experiencing a slight acceleration, typically associated with material release through outgassing. However, despite careful observations, astronomers could not detect any comet-like tail composed of dust or gas. Its velocity was far too fast to have originated from within our solar system, prompting astronomers to categorize it as an interstellar messenger. As it entered the public domain, the question on everyone's lips was, could this be a sign that we are not alone in the universe? Oumuamua had already passed its closest point to the Sun by 40 days when it was observed. At the time, it was positioned 33 million kilometers away from Earth. As NASA's telescopes delved deeper, they unveiled its peculiar elongated shape resembling a cigar, measuring between 100 to 400 meters in length and approximately 35 to 167 meters in thickness. Interestingly, it exhibited a slight increase in speed as it departed the solar system. This raised questions among scientists. What baffled them even further was the object's apparent acceleration as it approached Earth, followed by a sharp turn before heading back into space. Natural phenomena could not easily explain such behavior. Additionally, Oumuamua's rotation rate resembled that of asteroids within our solar system, and its trajectory indicated that it would eventually exit the solar system, venturing into interstellar space. Astronomers are still working to determine the age and planetary origin of the Oumuamua object. However, because they had limited time for observation, there are uncertainties in their understanding of its characteristics. The relatively low density of Oumuamua was a result of its internal strength, which was comparable to that of icy comets. On March 22, 2023, a new revelation emerged, suggesting that Oumuamua's acceleration could be attributed to a planetesimal relic exhibiting similarities to comets in our solar system. Another possibility was the release of entrapped molecular hydrogen resulting from the energetic processing of a water-rich icy body. While some speculated about the involvement of extraterrestrial technology in Oumuamua's creation, there was no evidence to support such claims. The notion that it could be an alien probe or spaceship was purely speculative. Similarly, suggestions that it might contain exotic materials not found within our solar system lacked substantial proof. Nonetheless, two researchers, Jennifer Bergner and Daryl Seligman, published their findings in the journal Nature, proposing that the release of hydrogen from trapped reserves inside water-rich ice was the most plausible explanation for Oumuamua's composition. The unusual characteristics of Oumuamua caused a stir on the internet and across other social forums, leading to the inception of Project Lyra in January 2022. This ambitious project aimed to launch a spacecraft from Earth's surface, catch up with Oumuamua in 26 years, and conduct a more detailed study. Initially, Jennifer Bergner, an astrochemist from the University of California, Berkeley, did not find Oumuamua particularly intriguing, as it did not align closely with her field of study. However, she was captivated when she attended a seminar by Daryl Seligman from Cornell University, who provided a detailed account of the interstellar object. Jennifer and Daryl joined forces to unravel the mysteries surrounding Oumuamua. They explored the effects of radiation on liquid ice. They calculated the object's mass to determine if it could store enough trapped hydrogen to fuel its acceleration. Their investigation also involved studying the structure of water exposed to warmth, carefully observing the shifts and gas releases during these processes. Jennifer's hypothesis offered a plausible explanation for Oumuamua's acceleration, attracting interest from Karen Meach at the University of Hawaii Institute for Astronomy. Despite Karen Meach finding Jennifer's hypothesis intriguing and creative, she maintained her belief that Oumuamua was an ordinary comet, releasing sufficient water, carbon dioxide, and carbon monoxide to propel its acceleration. And Meach was intrigued at the possibility of these releases going undetected by astronomers before now. Regardless of its origin, Oumuamua's journey through our solar system provided valuable insights into the nature of interstellar objects. As technology advances and more objects are discovered, astronomers will continue to uncover the mysteries of the universe. Although observing and studying Oumuamua from such a distance posed significant challenges, astronomers remain hopeful of gathering more data about this interstellar object. The upcoming Vera C. Rubin Observatory and plans for a new space-based telescope promise to enhance our understanding of the cosmos. The Vera C. Rubin Observatory telescope is a fascinating machine that will watch the entire sky from the southern hemisphere. In the past, it took a long time, weeks, months, or even years, to finish a survey of the entire sky, but this telescope will achieve that in a matter of days. Throughout 3 nights per 330 days annually, spanning a decade, it will undertake the legacy survey of space and time, fundamentally transforming our understanding of the universe. Distinguished by its unique 3-mirror system, the telescope will have an enhanced capability to observe a larger portion of the celestial sphere. While the 8.4-meter mirror currently resides within an external warehouse, a substitute mirror has been employed for testing. Upon the arrival of the authentic mirror, 16 grams of silver coating will be applied to its surface using the apparatus. Notably, the camera, an essential component, has been skillfully designed at SLAC National Lab in the United States, boasting 2 Guinness World Records as the largest camera and lens. Astronomers were particularly surprised by Oumuamua's escape speed, which measured approximately 26 kilometers per second. It is the fastest naturally occurring object to depart the solar system with such velocity, a feat impossible to achieve solely through gravitational interactions, even with planets like Jupiter or Neptune, which never intersected Oumuamua's path. It originated from beyond our local cosmic vicinity. As Oumuamua proceeds into interstellar space, its speed will gradually decrease to 1 kilometer per second. Models and estimates suggest that numerous objects of a similar nature traverse our solar system annually. However, detecting them remains a challenge unless we conduct frequent, practically nightly imaging of the entire sky with high sensitivity. This precise undertaking has been diligently carried out by the Pan-STARRS telescope for years, ultimately leading to the discovery of Oumuamua. Scientists unanimously agreed to label it as the first interstellar intruder. Notably, we detected this object simply because of its proximity to the Sun, as it journeyed through our solar system, orbiting the Sun, and passed by Earth. Such behavior deviates from the norm for objects of similar structure. Remarkably, Oumuamua even passed Mercury's orbit, an area rarely surveyed by our telescopes to avoid unintentionally pointing them toward the Sun. Consequently, its detection occurred only after it crossed the opposite side of Earth's orbit while exiting the solar system. We discovered it when it was approximately 23 million kilometers from Earth. Despite its miniature size of around 100 meters and its faint, reddish appearance similar to the Trojan asteroids encircling Jupiter, capturing any data about Oumuamua was a stroke of luck. Its color greatly differed from any known icy objects, failing to match the characteristics of comets, Kuiper Belt objects, or Centaurus. Furthermore, detailed analysis revealed the absence of molecular or atomic absorption or emission signals, further heightening the mystery surrounding Oumuamua. How were the declassified images captured? To fully understand the declassified images of Oumuamua presented by Michio Kaku, it is essential to understand the telescope used for capturing it and the accompanying theories that will bring you up to speed. The Institute for Astronomy are responsible for conducting the largest single research project known as Pan-STARRS. The project features 2 telescopes, with the first one called Pan-STARRS 1. Pan-STARRS 1 is positioned near the summit of Halakala on the island of Maui and boasts a 1.8-meter diameter telescope. It has the world's largest digital camera, boasting nearly 1.4 billion pixels. The Pan-STARRS telescope, a remarkable feat of scientific ingenuity, possesses numerous exceptional features that distinguish it from other telescopes. One of its standout characteristics is its expansive field of view. Unlike traditional telescopes that focus on a narrow patch of sky, the Pan-STARRS telescope boasts a panoramic perspective that spans an impressive swath of celestial terrain. Its wide-angle lens captures a vast portion of the night sky in each observation, enabling astronomers to survey and map large regions with remarkable efficiency. This expansive field of view allows for detecting and tracking celestial objects across vast distances, enhancing our understanding of the universe's structure and evolution. With its panoramic field of view and high sensitivity, the Pan-STARRS telescope was able to quickly detect and track this intriguing visitor. The observations made by the Pan-STARRS telescope provided valuable insights into the physical properties of Oumuamua. Its sensitive camera system captured detailed images of the object, revealing its elongated shape and peculiar tumbling motion. These observations, combined with data from other telescopes and instruments, allowed scientists to construct a 3D model of Oumuamua, providing clues about its composition, structure, and origins. The unique capabilities of the Pan-STARRS telescope also facilitated the measurement of Oumuamua's trajectory and velocity. By precisely tracking its movement across the sky, astronomers could determine that Oumuamua originated from beyond our solar system and was on a hyperbolic trajectory, indicating the Sun's gravity would not capture it. it would eventually continue its journey into interstellar space. This groundbreaking discovery marked a significant milestone in understanding the prevalence of interstellar objects and their potential impact on our solar system. Also, the Pan-STARRS telescope's rapid data processing capabilities played a crucial role in monitoring Oumuamua's behavior and characteristics during its brief encounter with our Sun. The continuous stream of data captured by the telescope allows astronomers to study Oumuamua's brightness variations, revealing clues about its irregular shape and surface properties. These observations provided tantalizing hints about the object's possible origins, spurring speculation about its nature and sparking lively scientific debates. Let's dive into the mystery surrounding the declassified image of Oumuamua. Scientists have been trying to determine its size, but different methods have led to various estimates. According to NASA's Jet Propulsion Laboratory, if spherical, Oumuamua could be anywhere from 320 to 1440 feet in diameter. That's about the height of a basketball player or a 14-story building. However, another theory proposed by NASA's Solar System Exploration Division suggests that Oumuamua is an elongated object resembling a long strip stretching over a quarter mile, equivalent to more than 4 football fields. Oumuamua looks more like a cosmic hot dog than a meatball in this scenario. But wait, another study has challenged the previous assumptions and suggests that Oumuamua might be smaller than initially thought. According to this study, Oumuamua could measure around 147 feet in length, 144 feet in width, and 24 feet in thickness. If Oumuamua were a building, it would be similar to a one-story house. Despite the debates about its size, there is a consensus that Oumuamua's shape is unusual for a space rock. It has a cigar-like or slender burrito-like shape. Some scientists speculate that Oumuamua may have traveled through the cosmos for billions of years, like a nomad of the universe. It could have come from a distant part of the galaxy and accidentally entered our solar system. It's like finding a seashell on a local beach and realizing it came from a faraway ocean. But here's where it gets really interesting. Imagine Oumuamua as a fragment of a larger cosmic puzzle. It might have once been part of a bigger object, like a planet in another solar system. However, a catastrophic event, similar to a cosmic explosion, shattered this larger object due to the immense gravitational force from its star. Picture a snow globe breaking apart, its pieces scattering in all directions. Oumuamua could be one of these scattered pieces propelled into space. What makes Oumuamua even more intriguing is its mysterious acceleration. It's like observing a bicycle suddenly gaining speed without anyone pedaling it. Oumuamua experienced a velocity boost, causing a slight change in its trajectory. It entered our solar system from above the flat plane where planets orbit, coming dangerously close to the Sun at about 1/4 of the Earth-Sun distance. After passing the Sun, this cosmic traveler continued its journey below the plane where planets orbit. Scientists have conducted studies to uncover Oumuamua's composition. Like a protective shell, it has a thick outer layer made of carbon-rich materials that solidified due to cosmic radiation during its long journey through interstellar space. Underneath this outer layer, Oumuamua reveals its dense inner nature, primarily composed of rock, possibly with metal traces. What sets Oumuamua apart is its lack of water or ice, which distinguishes it from typical comets or icy objects. Additionally, Oumuamua has a reddish color on its surface due to exposure to cosmic rays over millions of years. What does declassified images tell us about Oumuamua? Renowned theoretical physicist Dr. Michio Kaku, known for his profound understanding of the universe, has come to our aid in unraveling the importance of the declassified images of Oumuamua. Dr. Kaku and the scientific community were confronted with numerous perplexing questions regarding Oumuamua's strange properties. Its peculiar shape, resembling a fusion of a pancake and a cigar, defied conventional expectations and offered clues that it was not composed of ice like typical comets. Its lack of a cometary tail further supported the notion that Oumuamua was composed of a more resilient material, such as metal or rock. Scientists were captivated by these distinctive characteristics, yearning to unravel the mysteries surrounding this substance. Among Oumuamua's most astonishing attributes from the images was its acceleration, which contradicted the established laws of gravity. This confounding behavior ignited intense speculation among scholars, giving rise to many theories. Some postulated that Oumuamua was an ancient spaceship from a long-lost alien civilization. In contrast, others proposed more organic explanations, such as outgassing or a hydrogen iceberg. Dr. Kaku and his colleagues delved deep into these hypotheses, meticulously scrutinizing the available data and conducting sophisticated simulations in their pursuit of enlightenment. Driven by their relentless commitment, they increasingly believed that Oumuamua's visit to our solar system held profound implications for our understanding of extraterrestrial life. Oumuamua symbolized humanity's insatiable thirst for knowledge, inspiring both the scientific community and the general public. Dr. Kaku's proclamation ignited several discussions and debates among scientists, who united across diverse disciplines, pooling their expertise to decipher the enigma of Oumuamua. The allure of unraveling humanity's place in the vast universe and the prospect of communication with alien civilizations captivated enthusiasts worldwide, fueling anticipation for groundbreaking discoveries. As Oumuamua reinvigorated cosmic exploration, humanity embarked on a new era of awe-inspiring discoveries propelled by Dr. Michio Kaku's visionary leadership. As we eagerly await further revelations about Oumuamua, pursuing cosmic knowledge remains as captivating as ever. It challenges us to question established assumptions, embrace the unknown, and venture into uncharted territories. Driven by our unwavering curiosity, we embark on an epic journey, guided by Dr. Michio Kaku's pioneering efforts to unravel the mysteries of Oumuamua. Through this voyage, we strive not only to comprehend the enigma of Oumuamua, but also to gain profound insights into our existence and the limitless possibilities that lie beyond. Capturing a high-quality image of Oumuamua represents a significant milestone in our scientific quest, propelling us toward a greater understanding of the universe surrounding us. Thanks for watching. Check out the video you see on your screen right now. It's unbelievable.